I want to take this opportunity to use one of my own PowerPoints that I use in class with programming students. I'm going to record over this PowerPoint that I've created so that you can benefit from having me as your instructor, almost like in a classroom situation. So this is Variables and Constants. That's the name of Chapter 3 in your book. It's an important foundational chapter because you're going to get ready to code. So you need to know how to do all this. So we've talked about in Chapter 2 about coding the algorithm. That refers to the process of translating the algorithm into a language that the computer can understand. And I have my little saying that says, think twice, code once. But really and truly in this class, if you have to redo stuff, you're just learning as you go. This is all about learning, and a lot of it's going to be hands-on. So you're going to begin this whole process by assigning names to every input item, processing item, and output item. So when you've been doing your IPO charts, where you've been writing out sort of descriptions of what you're going to need, you are now going to start assigning names to them, and then a data type for that name and an initial value. So there's going to be 3 things you're going to start doing. Remember that every memory location has a unique internal address, and that memory location can only hold the one item that you've assigned to it. So you're going to be declaring a memory location. In C++, this is done with one statement that declares the name, the data type, and the initial value. Names can be descriptive, but they do have rules that we're going to have to follow. In other words, you can't have a name with spaces in it. So there's going to be rules, but lots of people use descriptive names because they're easier to remember, and also they help self-document code. Now, we're going to have 2 types of memory locations, variables and named constants. So variables can change value during runtime, which is when the program is running. So something that a user would enter would be a variable. Something that's calculated would be a variable. So because they can change during runtime. Now you can have a named constant also. For example given here is, suppose you were using a calculation with pi, which equals 3.14. You would put that as a constant. A constant cannot change during runtime. That's the rule of it. So when we declare these are going to be things that do not change during the program. They're fairly constant throughout life. Occasionally you'll name things as constants that maybe change once a year, and then that way you would update the code once a year. But if it's something that changes month to month, day to day, it would not be a constant. So every memory location declared must have a name, and a good name is one that is meaningful when you name it and for the people that follow behind you. You're going to see on the next screen the rules of C++. Every programming language will have its own set of rules. In C++, the rules are that your variable begins with a letter. It can only contain letters and numbers and an underscore. You may not have punctuation marks, spaces, or special characters. It cannot be a keyword, and those are reserved words that have special meaning in the language. They're listed in the back of your textbook. Cannot be one of those. Names are case sensitive, and this is the most commonly missed thing that students do in programs. For example, if you look in this screen, discount with a capital D and discount with a lower d might look alike to you, but they are not the same in C++ because one begins with a capital D and one begins with lowercase. So you want to keep that in mind. These are common guidelines that we use in C++. Uppercase letters are for named constants. So in other words, if you're using pi as a named constant, you would put all that word in uppercase. We use lowercase characters for variables. And if the name is more than one word, you use an underscore to separate the names if it's a named constant, like here, tax underscore rate. That's a named constant. But if the variable name has two words, you use what's called camel case. And that's where you start with a lowercase and then you have an uppercase in the middle that lets you know the next word is coming. In this example, it's gross pay. Now let's look at these. Why are these invalid names? So if you go through each of these and compare them to the rules that we're giving, let's look at the first one. Well, we can't start a variable name with a number, so that one's wrong. You cannot have a space in a variable name, so that's why this one won't work. In this name, you may not have a period, because that's not allowed in the naming rules. INT is a reserved word in C++, therefore your variable cannot be named that. And rate with a percentage at the end is invalid because it has a special character. So you can't have that as a name either. Looking at this, how many items can a memory location store at one time? Well, you should know by now it's one. A memory location can only store one thing at a time. And there's your answer. Which of the following is correct for the quantity variable? So the question is saying that quantity is given your variable, is to be your variable name. And if you look at these, which would be valid names if you were having a variable named quantity? Would it be quantity with lowercase, quantity with all uppercase, quantity with a capital Q, or any of the above? In this case, because quantity is a variable, it has to be lowercase. Remember, uppercase signifies that it's a named constant. Remember that variables don't start with capital letters. And then because these two are wrong, obviously number 4 would be wrong. Which of the following is a valid name for a memory location? Number 1 is jan.sales. 2 is 2 as in second quarter income. 3 is commission rate. And the 4th one is March with a dollar sign. So remember your rules, look back at the rules, and then you would discover that the following commission rate is the only valid name for a memory location. The first one has a period, which you're not allowed to have. The second starts with a number, also against the rules. And the 4th one has a dollar sign, and that is also against the rules in naming memory locations. What are the 2 types of memory locations a programmer can declare? Can you remember this? Named constants and variables. Named constants and variables. These are fundamental data types in C++, meaning they are built in, or called primitive. That's the other name for them. These all have to do with how you can assign a data type to your variable: short, integer, float, double, boolean, and character. There's also something called a string data type. String is a user-defined data type. It was not built into C++. It's not a fundamental data type. It's user-defined, meaning it's a group of instructions that the computer uses to create an object. And in this case, the class creates a string variable, which is an object with 0 or more characters. For instance, if you wanted to have a name as a data type and you want them to be able to enter the full name, then you're going to have to use a string data type. You can't use character data type because character data type is only for one character. So here we go on to character data type can only store one character. like a letter or number or symbol. You cannot store a person's name in the character data type. Short and integers, which are all int, which stands for integer, are also built-in data types. They store only integers, which is a whole number. It cannot contain a decimal. The difference between short and integer is the storage size of the variable. Short stores shorter numbers than an int variable type. In your book on page 56, it will list how many memory bytes are required if you use short or integer. Standard practice in this class is to use int for whole numbers. Memory is cheap now, so having to determine exactly what the range of the number could be and how much memory it takes up is not as important as it used to be when memory was more expensive. We also have real numbers, and those are defined with float or double as the data type. Again, the difference is in the range and the memory required. Double is more precise than a float number. And remember that all numbers cannot be not all numbers can be represented with accuracy to the penny. That has to do with rounding and how numbers are stored in C++. We'll talk more about that as we go. Do know that usually in this class you're going to use double when you're using a real number, and a real number has a decimal in it or could have a decimal in it. All of internal memory in any computer is down to a binary system. Binary meaning 0 and 1s. Everything gets converted to a 0 or 1. And we also have ASCII, which that is also a way to get characters down to binary. ASCII is a specific numeric code for each character on your keyboard. Then the ASCII is converted to binary. So on your keyboard, if you look at all the symbols on your keyboard, they also have an ASCII code that goes with that key. You can see those, a lot of them listed on page 59. Uppercase A and lowercase a are two different ASCII numbers. And then those numbers are converted into binary for the computer to use. But most important in all this is knowing that the data type lets the computer know how to interpret the memory location, that data. So if you declare something integer, then the computer's going to know whatever's stored there is a whole number or will be treated as a whole number. True or false? The string data type is one of the fundamental data types. As you think on this, remember what fundamental means: a built-in data type. And that's false. String data type is a user-defined data type. In the binary number system, the decimal number 32 is represented as 1, 2, 3, or 4. Well, I'm going to give you a little hint. It's not 4, if that would help you along with that. You have to know how to start and know that this would equate to 0 and 0 and 0 and 0. And then you would have this value here would be 2 to the 1, 2, 3, 4, 5th, I believe. Anyway, as you work out these numbers, this is the answer to that question. So the binary number of 32 is number 3. Okay? What's the ASCII code for the lowercase letter b, and how is it represented in the computer's internal memory? You can get all that from that chart on page 59. So if you look up the lowercase b, you're going to see a 98, and then you're going to see the binary equivalent of that out to the side. And that would be the answer to that question. Which data type can store a real number? Double, integer, float, or both A and C? It would be both A and C can store a real number. A real number has a decimal. The other step when you're declaring variables is called initializing. And It's done by using literal constants on everything except if you're doing Boolean. Boolean is initialized with either true or false. Everything else uses a literal constant. Now, unfortunately, literal constant sometimes gets confused with named constant variables. So a named constant is a variable that's not going to change. But a literal constant, of which there are two types, is that initializing variable amount that you do when you're initializing variables. So it's an item of data that can appear in a program instruction and be stored in memory, and they have to match the data type. So, for example, memory locations which are short or integer, you assign an integer to them, for instance, 0. Memory locations that are float or double have to have a real number assigned to them. For example, 0.0 or 0.0. Integers and real numbers get numeric literal constants. You can give them a plus sign, minus sign, numbers, and decimal points as long as it correlates to if it's an integer or a real number. And you can use E for exponential notation. Numeric literal constants, however, don't have a space or comma or special character. You can't have a $sign or percent. A numeric literal constant with no decimal point is an integer. And if it has a decimal point, it's a double data type. So you got to keep those straight in your head. If it's going to have a decimal point, you're going to use double. A character literal constant is the other data type for initializing, and it basically is a character, 1. Character is 1, and it's enclosed in a single quote. So if you wanted a value of something to start as X, you would put an X. Lots of times you start with an empty space or a space to initialize a character literal constant. We also have string literal constants, and those are used to initialize a string literal constant. You could put a word in as they have hello, but most of the time it's an empty string where you have the quotes and no space between them, and that's called an empty string. So here's how the computer assigns a variable to a memory location. A computer compares the values data type with the memory locations data type. And what that means is it's looking at your program data type versus the memory location data type. And if they don't match, a computer does an implicit conversion, which means it's going to adjust that number as it sees fit. And here's an example. If you assign integer 9 to a real number, then the number becomes 9.0 in memory. When a value is converted from one data type to another that can store larger numbers, that's called promotion. However, sometimes it gets demoted, which is a good example here. Suppose you can initialize a field called integer years equals 1.5. 1.5 actually becomes 1 because you have said it goes in an integer location, which can only hold non-decimal numbers. That only holds real numbers. Integers. So int only holds integers. Therefore, this gets truncated off. So that correct answer might be wrong in your program if you have incorrect data with an incorrect data type. Here's generally how we initialize. Short and integer equals 0. Double and float gets 0.0. Character gets a quote, space, quote. String is 2 quotes, no space. It's called an empty string. And Boolean could be true or false. And you choose one of these. It's not both. Here's how you declare the memory location in C++. You're going to give it a data type, a variable name according to the rules given, and an initial value, which is your constant literal, goes here. So use the correct syntax. That's the rules of the programming language. Just like in English, we have rules about periods, go at the end of a sentence. In C++, at the end, you get a semicolon. A common mistake is you forget your semicolon. Here's some examples of correctly named variables and their initial values. So if you look through here, they all have semicolons and they all have correct initial values. Naming a named constant is a little different because you put the word constant, the data type, and then the name and the value. A constant data type has to have an initial value. It has to have a value that never changes during runtime, so keep that in mind. Remember, it starts with const, the data type, and then in all capital letters, the name of the constant. Which of the following is a character literal constant? Is this a character literal constant? B, A, or both A and C? This is the only character literal constant, and this is how you know. First of all, a character cannot be two places, so that eliminates A. C, a character literal constant, does not have double quotes. It has single quotes. Therefore, it can't be C. And that only leaves you with B as the option. Which of the following is a string literal constant? So remember, a string can be one or more and in double quotes. So this is a string literal constant. That's a string literal constant. This is an empty string literal constant. So the answer to this is all of the above. If you assign the number 10.25 to an integer variable, what will the computer store in its memory? Now let's look and see. It'll store 10 because the number gets demoted because you have a real number you are trying to put in an integer. So it gets truncated off and you end up with 10. Write a C++ statement that declares and initializes an integer variable named population. So we're looking at this, so they've given us the variable name is population. We know it's an integer, and we know we commonly start those at 0. So here is the statement that you would write. Integer, int, population equals 0 with a semicolon. Write a C++ statement that declares the max pay name constant. It should have double data type and the number 25.55. So they've given you the name is max pay. They're telling you it's a named constant. The data type is double, and here's what we want in it. That statement would look like this. Constant, only not with ANT. It would be CONST. This is incorrect. Double, max underscore pay, all in cap, equal 25.55. And if you look closely, this is also missing a semicolon, which it should have. So there are two errors in this answer. Keep in mind it should say CONST, eliminate ANT, and that you should have a semicolon here. If you earn $10.25 per hour and work 20 hours, how much less would you be paid if your hourly rate was inadvertently assigned to an integer variable? Well, remember, if it gets assigned to an integer, it's going to truncate off. So what you're going to get is 10 times 20, which is $200. However, if you assigned it to a double, you would have made $205 because it would not have been truncated here. And these are examples of that. Thank you for joining me. I look forward to you joining me on the next video.